Welcome to your grade 12s. Today I want us to look at the sum to infinity. Okay, mathematics grade 12. Alright, so look, this is whereby we talk about the converging sequences and the geometric sequence, okay? Yes, so the sum to infinity has emerged from that, more especially fundamentally on converging sequences. Alright, when we talk about converging sequences, you know that we talk about the sequences whereby at some point the term values they become constantly 0, 0, 0, 0, and that's going to also affect our sum because our sum is also going to be constant at that particular point because we're adding zeros. Okay, yes. So the significance of sum to infinity or calculating the sum to infinity is to emphasize or to stress the fact that we want to get the sum of the first terms up until the last term, whereby after that term we get zeros. So I mean that's going to be our sum to infinity, because our sum is not increasing, or our sum is not changing, or whatever the case may be after that particular term. I hope you get it right. Yes. So the formula for the sum to infinity, is equals to sum to infinity is equals to a. The value of a is the very first term, 1 minus r, the common ratio. Okay. Yes. So you know that we are trying to calculate the sum. We've talked about the sum. Please don't confuse the two, okay? Yes, we've talked about calculating the sum in geometric sequences, which is, let me just write it here, which is Sn is equals to a 1 minus r to the power of n over 1 minus r. Okay, the reason why I noted this down is to show you that this comes from this, okay? Yes. Because also the sum, right? But now we're calculating the sum to infinity in the convergent sequences, okay? Yes. So you know that in the convergent sequences, at some point whereby the value of r, our value of r is smaller than 1 and greater than -1. So it's between those two places, between 1 and -1. So that it could be 0,8, 0,5, which is half, 1/3, and an end, okay? Yes. So at some point now, when you say the value of r, which is the common ratio to the power of something, at some point you know that in a convergent sequence we're going to get zeros. So at some certain position, which is the end, okay? Yes. At some point we're going to get 0, okay? Yes. So this is going to be 0, 1 minus 0. So our Sn will be equals to a multiplied by 1, which is a over 1 minus r. Okay? Yes. I hope you get that. Okay. Yeah, so let's have this example here, which is given. Okay, so the example, by the way, this is a very important formula. Okay, yes, which we're going to apply right now. Okay, this is a formula for the sum to infinity, but don't worry, they give you in your formula sheet during exams, tests, whatever the case may be. But please, when you're about to answer the question that says calculate the sum to infinity, please note down first the formula so that you can get some. Okay, so for answers number 1, alright, so number 1 says calculate the sum to infinity. We have given a sequence there, 9, 3, 1, 0, 3, 3, 0, 1, 1, 0, 0, 3. Okay, so you can clearly see that it's a convergent sequence because at some point we're going to get zeros. Okay, so let's calculate the sum to infinity, meaning that let's calculate the sum up until to the last term, whereby just before we get 0. Okay, yes, and reach 0. Okay, yes. So I think at some point maybe if we could try to work out on it, whereby we want to clearly see which position in the sequence we're going to get 0. Maybe it could be around 1920, around there. Okay, yes, 1019 or 1020. Mobile will get 0. I think so. Okay. By the way, let's calculate the sum to infinity. Our sum to infinity will be equal to a over 1 minus r. Okay. Yes, so it's going to be equal to the very first term. The very first term is 9 over 1 minus what's our r? Okay. Let's find our r. So it's going to be t2 over t3, which is 3 divided by 9. So this cancels this, we have 1. This cancels this, we have 3. So it's 1 over 3. And therefore our sum to infinity will be equals to, let's patch it to the calculator. So 9 over 1 minus 1 over 3 is equals to 13, 5. So 13, 5. That's how it goes. So that when you add all of those terms up until to the last term whereby just before we get 0, we're going to get 13, 5. Okay? But you can try to take on this and try to look at which term will be equals to n. Okay? Yes. So that's how it goes. Please don't forget to subscribe for more Connects. Have a great day. Cheers.